So here we have a scenario where we have two cones, one in the top and another one in the bottom. And then when we introduce a plane that is intersecting those two cones, which is shown here in blue, notice that we are creating a certain shape on the intersection. Right now, it looks like an oval or some kind of a stretched out circle. But when we rotate this plane, notice that the shape of the intersection, it changes. Now it's looking like a parabola. And this is the scenario that we will be discussing, where we have the intersection between the plane and a cone, where the intersection, it is this parabola shape. And notice that there are different angles where this is occurring. But the intersection, it's a two-dimensional figure. So let's look at this from the coordinate plane. So as we have shown before, this intersection between the cone and the plane is what we're going to be discussing, which is a parabola. Let's consider a parabola that is opening upwards. We define a parabola in the coordinate plane as a collection of points that are equidistant to a point, which we are going to call it a focus, and a line, which we are going to call it the directrix. The focus point, it's always inside the parabola, and the directrix, it's on the outside of the parabola, and it is always perpendicular to a line that passes through the focus. And this is also shown in the intersection between the plane and the cones. Here we got our focus, and here we've got our directrix. But now let's visualize this definition. So let's consider this parabola, which we have here, our focus point, which we have here, and our directrix, which we have here. This line in blue will represent the distance. Now let's look at the distance between the focus and the directrix. But now when we choose different points in this parabola, right now let's consider this one. Notice that the distance from the point to the focus, it's 7,4, and it is also the same distance from the focus to the directrix, 7,4 as well. The distance are equal. But what if we choose another point? The distance from the focus to the point is 551, and it is the same from the point to the directrix, 551. The distance will always be equal. Let's choose another point. The distance from the focus to the point is 1175, and that is the same from the same point to the directrix, 1175. So regardless of which point we choose in the parabola, the distance can change in value, but that distance will always be the same towards the focus and towards our directrix. So now that we have a better understanding about the parabola, let's discuss some important parts which we need to consider to define the equation of this parabola. The location where we are changing direction, this is what we call the vertex of our parabola, and it's always important to know its location. And the location, we will always represent it with a coordinate point. Let's call that location h, k. And the distance that we obtain from the vertex to the focus, it's what we're going to define as the focal distance. And we use the letter P to represent that distance. But because the vertex is a point in the parabola, and remember that parabolas is a collection of points that are equidistant to the focus and the directrix, the same distance that we have from the vertex to the focus, it is the same distance that we have from the vertex to the directrix. And these are the two pieces of information that we need to define the equation of a parabola. The standard equation of a parabola can be defined as x minus h squared being equivalent to 4p y minus k, where p is the focal distance and where h and k it is the location of the vertex. And x and y are any other point in the parabola. Now let's show the equation of other parabolas if we were to change the direction of the opening. Right now, we have only discussed a parabola which is opening upward. So if we have a parabola that is either opening upwards or downwards, we can use the equation that we had defined previously. Now, what's going to determine if we're facing up or down? Well, that is the location of the focus. Because if the focus is on top of the vertex, we are going to say that the focal distance, it is positive. But now, if our focus is below the vertex, then we are going to say that the focal distance is negative. So the equation remains the same. The value that we assign for P is what we are going to be using to give direction to the parabola. But I do want to make a point here. It doesn't make a lot of sense to say that we have a negative distance. The length of a distance, it's always positive. But we are just going to use the symbol of negative to indicate direction. Positive, we're up and up. Negative, we're going down. But the length between the distance from the focus to the vertex, it's always a positive line. We just use the symbol of negative to indicate direction. If we have a parabola that is either opening to the right or opening to the left, we have to use a different equation. And when we compare both equations side by side, the only difference is which variable is getting square. For a vertical opening, the variable of x is getting square. And for a horizontal opening, the variable of y, it's getting square. And what's going to determine the direction? The focus as well. If the focus it's on the right-hand side of the vertex, we are going to say that we have a positive focal distance. And if our focus is on the left-hand side of the vertex, we are going to say that we have a negative focal distance. And these are the 4 different types of parabolas that we will consider. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.